For our next talk, we have a few speakers joining us over Zoom. Dr. Farhan Ahmed Karim from the Microelectronics Research Lab, Shahzaib Kashif, a research assistant at MERL, and a co-founder of Silicon Space, Talha Ahmed, also a research assistant at MERL and co-founder of Silicon Space, and Mahnoor Ismail, also a co-founder of Silicon Space. With that, take it away.
Okay, can I start?
Yeah.
Hello, everyone. Good afternoon. I am Mahnoor Ismail, recent software engineering graduate of UIT. Today, I will be presenting ChipShop, that is a cloud-based GUI for accelerating SoC design. So let's get started with the agenda of this talk. First of all, in introduction session, we will talk about the problem statement and the introduction of ChipShop. Then in second session, that is feature, we will talk about all main feature of our project, namely web-based SoC generation, FPGA mapping and BITSTREAM generation, IP integration, and real-time collaboration and version control. And then in technical section, we will discuss about the applications of ChipShop and tech stack. Then finally, in last session, that is conclusion, where we have a question answer session. So next slide. So first of all, problem. For many people and organizations, designing a system on chip is out of reach due to the high level of technical expertise required. This restricted access to SoC design could stifle innovation and advancement in the industry. There is a need for a more accessible and user-friendly approach to design SoC. The method should make the design process easier and more efficient. In addition, it should democratize access to SoC design by making it more broadly available to people and organizations without deep technical knowledge. So this issue is already resolved by Chipyard. However, using it and creating customized SoCs with it takes more technical know-how, making it only useful for some specified users. So in ChipShop, next slide. To further democratize access to SoC design, we are developing ChipShop, a web-based graphical user interface built on top of Chipyard that enables users to configure and accelerate the SoC generation process. By providing an easy-to-use interface for Chipyard configuration and supporting FPGA emulation and mapping, ChipShop streamlines the SoC design process and makes it accessible to a broader range of users. With its support for adding new IPs and at automatic black box generation and integration for user-provided RTLs, ChipShop further enhances the design capabilities of user. Looking ahead, we plan to extend ChipShop's capabilities to support FireSim and BITSTREAM generation, further expanding its usefulness and democratizing access to SoC design. So with its real-time collaboration and version control features, ChipShop is also well suited for large teams working on complex design. Okay, next.
Hi guys, this is Shahzaib, and so let's dive in with the features of ChipShop. So the first feature that ChipShop includes is web-based system-on-chip configuration. Along with that, there's also support for mapping the SoC IOs to FPGA components and the BITSTREAM generation on some supported FPGAs. And along with that, there is also feature to integrate the custom user-defined IPs as a black box inside the SoC. And there is also a feature to enable real-time collaboration, so teams can collaborate on a single design on a single SoC project easily. And there's also version control systems, so nothing breaks inside the hierarchy of changes. So let's deep dive in with each of the features. So the first feature that we are providing is a web-based system-on-chip configuration. So this is simply just to it is being done inside Chipyard by following the Chipyard's cake patterns design pattern. So in this, that the user can add, remove, or edit the cake layers, also known as configs, inside a customized configuration. So this entire methodology or this entire phenomena is implemented in a graphical interface. So user can create their system on chip by adding cake layers configurations, like a user wants a medium core or a small core or a large core. So user can just easily pick up its configuration, which we call a cake layer, and add it inside its the SoC stack that we say, or a cake, or the system on chip. So it is similar to as being done in a Chipyard, but with a code interface. But in ChipShop, we are providing the same thing, but in a no code interface. So we can target a large number of users that do not have enough technical expertise to cater or play with the Chipyard's code interface. And along with that, there's also feature to edit the configurations or the cake layers inside the Chipyard cake pattern. So like, let's say if a user wants to add a medium core, but it doesn't want to use all of its parameter as it is, but want to change one or two parameters that are not done by any default config. So user can also do that by selecting any of the config and editing its desired parameters to create his own custom cake layer inside to be used inside his system on chip. So here's a little demonstration of how this thing is done inside the ChipShop. So let's say user wants to configure this small core config already defined in Chipyard and provide some parameters with his own custom defined values. So you can see that config is gone as a custom config instead of being the generic one. So this entire idea is presented as user can create configurations by not diving into the code and finding the config parameters and then changing its values. So in order to create his own custom config with code interface, rather than it's done quite easily and in a much neater way, and the user doesn't need to know all the technical aspects of it, rather than just can create a SoC with its custom configuration right away. So that's one feature of it. The second feature which we're offering is FPGA mapping and BITSTREAM generation. So as Chipyard already supports BITSTREAM generation through Vivado on only two FPGA targets, namely RT-A7 and VCU118. So that entire process flow is also integrated inside ChipShop. So once user has successfully generated a SoC, he can further process it towards FPGA BITSTREAM generation by mapping its IOs onto the FPGA components, as well as generating its BITSTREAM for the available targets. So that thing is also done. And so the third feature is real-time collaboration and version control. So the ChipShop is not just limited to the user selecting SoC config and generating it and then goodbye. It's not just doesn't finish there. There's also a feature of, like, if you're generating a SoC, you have created a project. Now you can share this project with your fellows, your teammates, so they can further on collaborate, make changes in the system on chip configuration, their cake layers, and also they can create bit streams by providing different configurations and generate bit streams for every change. So SoC now also offers your project to be shared with your teammates, your peers, and as well as for each and every change being done inside a project, a version history is being maintained. Like for every change, there's a separate version of that project. So you can always go back to the previous version if in case if something fails or something breaks. Right, so there's this is a little mock-up of how this version control and collaboration is implemented inside the ChipShop. So on the left side, you can see all the projects created by a user are displayed. And along with that, on the bottom left, there's also a tab that indicates how many people this project is shared with and who can collaborate on this. And on the right-hand side is the version control being displayed of a project, in which it says that what user has created what change. So this way you can always go back to any previous version you want, and you can see what user has done which thing. And next.
Hello everyone, I'm Talha. Black box integration or IP integration is a fourth feature of our ChipShop. Basically, it is working on the feature like if we have an RTL implementation or intellectual property, we are going to integrate this intellectual property in CHISEL. So CHISEL offers a black box black box library, so we can use as a black box of our RTL implementations and integrate this black box into the Chipyard. So we are automating this process, like we are converting. Yeah. Okay, so like this, we have uploaded an intellectual property like justread.v, and it will working as a memory mapped input output. So it will be mapped at a memory address. So it will identify the memory address of which it will be mapped, and all the RTL parameters will be present. So we can update the RTL parameters according to our need. It will automatically upgrade all the parameters in the CHISEL implementation, which is implemented as a black box. Okay, so we have created a software utility named chiV. It is a CHISEL interfacing for Verilog IPs. Basically, what it is working like, it is converting our Verilog intellectual properties into a Verilog abstract syntax tree, which will further analyze and use for creating modules for CHISEL black box. Like if we have a module implementation of GPIO, so it will be converted into the Verilog abstract syntax tree, and further it will be analyzed to create a CHISEL black box of top module of GPIO, and in further it will be attached into the Chipyard or ChipShop. Like, okay. Okay, so what are the applications? We can use this ChipShop in different things. Like if anybody like me, I'm a software engineer, so I have less understanding of software designing. So I can simply use ChipShop, which is completely hosted on the cloud. I just need to type the URL of the ChipShop into the browser and access to the ChipShop. I will definitely go into the ChipShop and parameterize my SoC and generate the SoC, and whatever I want to do, I can do it. So it will be a great application for like me and the users which are like me. Okay. We can also use this ChipShop in educational purposes, which will be a great learning tool for a student, and we can also generate different SoC designs easily and analyze the RTLs on whatever we want to do. It is also used for rapid prototyping if we want to generate SoC, so we can easily generate SoC from it. It will be also used for some small companies or startups, but it will definitely be need some upgradations. So it is a nice feature. Version control and team management feature of ChipShop will also offers to the large organizations, which will be used to accelerate SoC design. Okay, so what are the technological stack we are using? We are currently using CHISEL, Scala, Python, Django. REST is basically used as the middleware. React is used as the front end, and we are completely Dockerize our system, so we can easily host it into the cloud interface. Okay, so this is our team, Dr. Farhan, Ahmed, Karim, he's our professor, Shahzaib, Talha, and Mahnoor, Ismail, and 2 of our junior interns. So there's the whole idea for. Okay, so we are going to further extend the project to the FireSim, so we can integrate FireSim also. So, and furthermore, we are also going towards the BITSTREAM generation through some open source tools. Like currently we are generating, we are using Vivado for generating BITSTREAM, but if you know, there is a tool named FPGA, which was, I think, SymbiFlow. We are going to integrate SymbiFlow to generate BITSTREAM for also, because it will be a open source tool, so we should try this. Yeah. Okay, that's the whole idea of this project. Thank you so much. Any questions?
All right, thanks all. So any questions?
Yeah,
Question?
question.
Yeah.
So you showed in the really cool work. I think from the Chipyard and FireSim side, we wanted a GUI for a while, but we don't have any front-end devs that really want to do it. So amazing.
Thanks a lot.
But I guess discoverability of configurations. So you showed like you're configuring rocket cores, you're configuring boom cores with some sets of config mixins. do you do some sort of like automatic exploration of the mixins so that you can configure SoC, kind of like exposing it out to the world? Or is this you chose a particular set of configs and you like hard coded it into the GUI right now?
For now, this work is in progress. So for now, we have used some static configs hard-coded inside our GUI, but obviously for the final product, we plan to include all the configs that are inside the Chipyard, including the rocket configs, boom configs, and node accelerator, Gemini, and etc. All the configs.
And I guess second question is not all of the configurations are valid depending on what knobs you turn in the configs. Do you do any sort of do you do anything special to determine what the range of valid config like parameters are? For example, you can't make a cache that's like an L1 cache that's like 1500 gigabytes, right? Do you do any sort of like fancy work, or do you just send it out to the tool for Chipyard to basically throw an error and then you report that back?
Yes, we are trying. As we are trying to add as much exceptions we can, but certainly not now. We have implemented it, but we plan to implement such kind of exceptions as well inside it.
Thank you.
Yeah. All right. Any other questions?
Yes, thanks. Thanks for the talk. Two questions.
Thank you.
One, what's the status of the project? So how usable is it right now, and how accessible is it to potential users? And the second question is, do you also, instead of creating the bitstream directly, export basically the CHISEL file for the configuration, basically to use your tool as a configuration generator? Thanks.
This tool is not available right now, but it will be within a month or so, because it's in the development stage currently. It's a work in progress. So we plan to release it within a month or so. So it will be available soon enough. And regarding the configuration part, yes, we do not provide the CHISEL, but we provide the generated RTL once the SoC is generated. So you can download it from our GUI. And as far as BITSTREAM is concerned, so you can also download the BITSTREAM once it's generated, and it will stay there as long as your project is inside your dashboard. So yeah.
Any other questions? I have one. So how do you manage the infrastructure in the backend? So like a user comes and asks for a bitstream build. Are you launching machines on the fly, or you like have some pool of machines? Like, how does that work?
Sorry, I didn't get that.
Oh, sorry. So how are you managing, so for like the heavyweight operations, like building a bitstream, or even just doing like elaboration or something, how are you managing the like backend infrastructure once a user requests some operation?
Yeah, we are we plan to host it on the cloud, but right now it's not hosted on any cloud. It's just running locally on a Dockerized system. So there's no such kind of management yet, but it will be included in the final hosted version. Yeah. So it will be on the cloud, you pay for the cloud credits, and it will be fired up on the cloud, the bitstream generation and the SoC generation process.
Cool. Any other questions? All right. Let's thank our speakers again. Cool work.
Thank you guys for listening. Thank you for your time.